Hello friends, in this second part of operators, we are going to see this commutator brackets using position, momentum and angular momentum. Okay, so this is the second part, and we know that classically this angular, first we define this angular momentum. Angular momentum is a moment of momentum is angular momentum. So that term in classical we are already known. A position x and momentum p, and therefore we are writing this x operator, p operator and this L operator. Okay, so this L is angular momentum. This angular momentum is defined as L is equal to vector L is equal to this R cross P, R across P. Okay, where R is a position vector and P is its momentum vector. Okay, now this P has three parts. So along the Px, Py, Pz. So this R vector is written as I x plus Jy plus kz. I, j, k are the unit vectors, and this p is equal to I px plus j py plus k pz. I, j, k are the unit vectors. So this p has three components: the px, py, pz, and r is written in terms of x, y, z along the x, y, and z, and therefore this cross product L can be written as is equal to this R x plus Jy plus kz cross of I px plus j py plus k pz. So this L is equal to I j k x y and z, and this px py pz. Okay, now solve this modulus is equal to, this can be written as I into bracket this ypz minus zpy minus zpy minus of j, so it will cancel, this cancel, so this xpz xpz minus zpx plus k into bracket, so k it will gone, then xpy minus ypx. Okay, so this is the L, and this can be written as this L vector is equal to, so this is the I lx plus jly plus k lz, means this Lx is equal to ypz minus zpy. Ly is nothing but the xpz minus zx, and this Lz is equal to xpy minus ypx. Okay, and therefore we write these three components as, so this Lx is equal to y pz minus zpy, ly is equal to xpz minus zpx, and lz is equal to x py minus y pz. So these are the very important equations we required to solve the relations between these two. Now we are going to solve one commutator with Lx and x. Say Lx and x. What is the value of this commutator? Now we are going to see. We are going to see the modulus of is a commutator of Lx and x. Okay. So unless it is act on some wave function, it has no meaning, and therefore this is x on sine is equal to xlx. You can write it as xlx. It is okay. lxx चलेगा lx. So this lx x is equal to, now this lx is equal to y pz minus zpy, and pz we know. Okay, so this is the pz is dabba by dabba z, and that can be written as lx is equal to, so this lx is equal to y of I h cross zpy plus minus y pz. So this can be written as I h cross z dabba by dabba y minus y dabba by dabba z. Dabba by dabba z. Okay, so this we are written because of that we are taking this minus 1. Okay, and therefore this can be written as, so modulus of I h cross this z dabba by dabba y minus y dabba by dabba z of x. So Lx, commutator of Lx is equal to Lx x is equal to sine, it acts on the sine, is equal to into I h cross into bracket this into x, and therefore this is z dabba by dabba y minus y dabba by dabba z of x minus this into x. Now this x into this z dabba by dabba y minus y dabba by dabba z, bracket completed sine. Okay, is equal to I h cross z in sine, and therefore this is the z dou x by dou y minus y dou x by dou z minus xz, this xz dou by dou y minus xy dou by dou z sine. So this is sine, this becomes sine. Here also we write this sine and sine, and therefore here this x as a constant. Okay, and therefore this can be written as, this is z, this can be written as I h cross zx dou psi by dou y minus yx 2 से by 2 छेड़ minus x छेड़ 2 से by 2y plus yx 2 से by 2 छेड़ bracket completed. Okay, now see this x छेड़ and this term will cancel and these two are cancelled, and therefore this can be written as RH cross 0, and therefore this Lx of capital X is equal to 0. Similarly, we can write this Ly of y is equal to L z with H z is equal to 0. Means Lx x commit to each other, Ly y commit to each other, Lz z are commit to each other. What will happen when we write Lx with y? Okay, so that we are going to see. So instead of that, this is the y, capital Y, and therefore this can be written as Lx. We are at here the Lx is equal to, so that is the IH cross z 2 by 2y minus y 2 by 2z into y sine. Okay, is equal to IH cross into bracket this into this, so this is z 2 by 2y minus y 2 by 2z of y sine minus y z minus y into z 2 sine by 2y minus become 3, this will become 4 plus, and this becomes y into y square 2 sine by 2z. Sorry. Okay, then bracket completed. Now see what happens here. Is equal to IH cross into bracket z double by double y of y sine minus y double by double z of y sine minus yz 2 sine by 2y plus y square 2 sine by 2z as it is. So here this y is there, and therefore this becomes IH cross z sine plus this yz 2 sine by 2y minus this y square 2 sine by 2z plus yz 2 sine by 2y plus y square 2 sine by 2z. Okay, see this term and this term is cancelled to each other. This y square term and this will cancel to each other. What remains is IH cross z sine. Okay, and therefore, so it is LXY sine is equal to IH cross z sine. Therefore, the value of the commutator XY is equal to IH cross z. Similarly, LX with y, the commutator of Lx with y is equal to I h cross z, and therefore this Ly Lx with z is equal to I h cross y,